How are you, my friends? This is Calculus 1 solved questions about increasing and decreasing. Question number 1, determine the intervals where the function f of x is equal to 2x cubed plus 9x squared minus 24x minus 10 is increasing or decreasing. The idea is simple. First, we look at the function and then we find the derivative here. Directly we start 6x squared plus 18x minus 24, and then we try to factor the derivative f prime, take 6 out, and then x plus 4x minus 1. Easy to factor. After that, we have to find the critical values. The critical values, they come from f prime at c is equal to 0, or f prime at c does not exist. Now here, what will make the f prime 0? It will be minus 4 and 1. So these are the critical values. So we make a table of signs. This is from the complete algebra course, lecture number 25. You can make this table of signs. You can review if you want. And then here we study f prime. See, this is f prime here. So we write x plus 4, x minus 1. We choose a test point. Let's say here number minus 10 maybe. This will be negative, negative. Between minus 4 and 1, we choose 0. This is plus and minus. And after 1, we take maybe 7 plus plus. If we put 7 here in the x, so this will be multiply negative and negative will be positive. Multiply here, you get negative. See, this is positive. That means f prime is positive. So I put an arrow here. That means the f is increasing. F prime is negative, f is decreasing. F prime is positive, f is increasing. Now we can answer the question. F is increasing where? On minus infinity to minus 4, union 1 to infinity. F is decreasing from minus 4 to 1. Now we can see another question. Determine the intervals where the function f of x is equal to x to the power 5 over 3 minus 5x to the power 2 over 3 is increasing or decreasing. Now for question number 2 solution, we take the function f of x is equal to x to the power 5 over 3 minus 5x to the power 2 over 3. Let's find the derivative as usual. 5 over 3 will come down, x to the power 5 over 3 minus 1, which is to the power 2 over 3 minus, there is a 5 here, times 2 over 3 x to the power minus 1/3. This one, x to the power minus 1/3, we can write it in the denominator here. It will be cube root of x. Then we find the LCD. So in the first term here, we can multiply up and down by x to the power 1 over 3. So we will get 5x minus 10 divided by 3 cube root of x. This is the final expression for the derivative f prime. Now we need critical values. They occur if f prime at c is equal to 0 or f prime at c does not exist. So we can look here. What will make the derivative here 0? So 5x minus 10 is equal to 0. It will be 2. See here, 10 over 5. And then what will make the derivative undefined when x is 0? So we take these two numbers and we put them on the number line to study f prime. So I write now the factors here, x, cx, or cube root of the x. That's the same study here. You can put here cube root of x because we need only the sign. If this is minus, x is minus, so the cube root will be minus. If x is plus, between 0 and 2 and 2 to infinity, it will be the cube root is plus. And also 5x minus 10 here. If I take a negative number here less than 0, maybe minus 5, this will be minus here, this will be minus. Between 0 and 2, if I take 1, this will be plus, this will be minus also. If I take a number greater than 2, maybe 10, This will be plus and plus. So when you multiply minus with the minus, you get plus. That means f prime is positive. F prime is positive. The function is increasing up here like this. And then f prime is negative. The function is decreasing, etc. Now, where is the function increasing? From minus infinity to 0, union 2 to infinity. And where the function is decreasing? From 0 to 2. Another function here, determine the intervals where the function f of x is equal x to the power e to the minus x over 2 is increasing or decreasing. Now let's start finding directly the derivative of this function. Since we see x times e to the power minus x over 2, it will be the product rule u prime v plus v prime u. So y prime, which is the same as f prime, the derivative of the x here is 1, e to the power minus x over 2. And in the formula, see, we have a plus here. Now we find the derivative of the second term here. So it will be minus a half e to the power minus x over 2 times the x itself, which is u. Now here we can take a common factor, e to the power minus x over 2, and we can replace it in the denominator with the positive power. There is a 2 here. Multiply here up and down by 2. Finally, you get y prime 2 minus x divided by 2 times e to the power x over 2. Now, the critical values here, it will be what will make the y prime 0, it will be x equals 2. Here we cannot have any value for x that will make the denominator 0, which will make f prime does not exist. No values for the x there. So only we have x equals 2. So we say f is increasing if f prime or y prime is positive. So 2 minus x greater than 0. That's easy, linear. No need here for table of signs. This is always positive, e to the power x over 2. This is always positive. Times 2, this is always positive. Remember here. So only we study 2 minus x greater than 0. X will be less than 2. This is a linear inequality. So f is increasing from minus infinity to 2. F is decreasing if y prime or f prime is negative. So 2 minus x less than 0, x will be greater than 2 from 2 to plus infinity. Question number 4 is a little tricky question. You can try it yourself if you like, and then you can check the answer if you are ready. Same question, determine the intervals where this function is increasing or decreasing. F of x equals x times square root of x squared plus 1. Ready? Let's go. Let's find y prime. Also here we have to use the product rule, u prime v plus v prime u. So y prime will be 1 times the square root of x squared plus 1 plus the derivative of this v, which is 1 over 2 square root of x squared plus 1 times the derivative of the inside, which is 2x, times the x, which is the u. Okay, so we make here LCD. You can cancel this 2 first. See, and you make here x squared. And then you find the LCD. So the LCD will be square root of x squared plus 1. Here, multiply up and down by square root of x squared plus 1. So finally, you will get 2x squared plus 1 divided by square root of x squared plus 1. No critical values here. Why? The derivative y prime, we can see this is always positive. Whatever the x can be negative. But x squared is positive. 2 times x squared will be positive. Plus 1 will be positive. All this in the denominator will be positive. So the derivative here is always positive. No decreasing interval for this function. No value for x will make the function decreasing. So the function is increasing on the entire domain from minus infinity to plus infinity. Let's see another one here. Question number 5. Determine the intervals where this function f of x, ln of 2x divided by x is increasing or decreasing. You can try it if you like. Let's find the derivative here. We have to use quotient rule. Remember, u prime v minus v prime u divided by v squared. So y prime will be u prime ln of 2x. The derivative will be u prime over u. So 2, the derivative of 2x divided by 2x. So it will be 2 over 2x times the x here, the v. This is the v here. See this v? It's coming from the denominator. Minus v prime, the derivative of the x is 1 here, times ln of 2x, which is the u. All of this u. Okay, divided by x squared. Now, don't be confused with the u that I said at the beginning. This is ln of 2x. See, this is ln of 2x. This is u here, right? And this is the x is v. So first I need u prime, the derivative of ln of 2x. Now you can use ln of u. So you can take 2x as another u, which will be in the derivative u prime over u for only this one here, ln of 2x, the derivative of 2x over 2x. Be careful there. Now you simplify that, you cancel here the 2, you cancel the x, you get 1 minus ln of 2x divided by x squared. To find the critical values, we can take the derivative is equal to 0 or the derivative does not exist. So we take x equals 0 here, you see, that will make the derivative does not exist because it's undefined. 1 minus ln of 2x is equal to 0. Take 1 on the other side or take ln on the other side, it's the same. You will reach this equation here, ln of 2x is equal to 1. Then you can use pre-calculus course, lectures 4 and 5, to go from logarithmic. This is a logarithmic equation. You go to exponential. ln means the base is e. So I can change it to exponential. 2x is equal e to the power 1. So x will be e over 2. Now here x equals to 0. It is not in the domain, right? See, I mentioned that here. Argument greater than 0. So x should be greater than 0. Remember that. So that's why we cannot take these numbers here below 0, before 0, less than 0. We cannot take it into consideration because the argument here should be positive. Remember, any logarithmic function, the argument should be positive. So let's do a table of signs. So I can put 0, e over 2. Just take any number there. This will be positive and this will be positive. Take a number between e over 2 to infinity. You can choose any big number like 100. So this will be positive, this will be negative. So this is increasing and decreasing. So the function is increasing from where? From 0 to e over 2. And this function is decreasing from e over 2 to plus infinity. We don't consider the values less than 0. For more questions on increasing and decreasing functions, you can see lecture number 16. And for more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.